Greetings to all. This is Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the threads, types of threads and multi-threading models and operating systems. First one, thread. The thread refers to the single sequential flow of activities being executed in the process, and it is also known as the thread of execution or the thread of control. It comprises the thread ID and a program counter, register set, and the stack. It shares with other threads belonging to the same process its code sections, data sections, and other operating system resources. The traditional process as a single thread of control. Next, if the process has a multiple thread of control, it can do more than one task at a time. Here we have the diagrammatic representation of the single threaded process and the multi-threaded process. As the diagram shows, we have for the single threaded process, we have the single thread. Here we have that code, data, files, registers, and the stack. As for the multi-threaded process, we have the multi-threads. We have the several threads, that is several processes of executions are held here. Next one, types of thread. We have that two threads are implemented in the following two ways, that is user level threads and the kernel level threads. First one, user level thread, that is user manages the threads. Second one, kernel level thread, that kernel level threads, operating system manages the threads acting on kernel. Next one is multi-threading models. For multi-threading models, we have the three types, that is many to one, one to one. Next one, many to many. First one, many to one. Many to one, many user level threads mapped to the single kernel thread. One thread blocking causes all to block. Multiple threads may not run in the parallel on the multi-core system because only one may be in kernel at a time. Few systems currently use this model. Example for this, a many to one thread is solarizes grain threads, and that is GNU portable thread. Here we have the diagrammatic representation for the one to one many to one thread. That is, here we have the one kernel, followed by this we have the multiple user threads. Next type is one to one thread, that is each user level thread maps to kernel thread. Creating a user level threads creates a kernel threads. More concurrency than many to one. Number of threads per process sometimes restricted due to overhead. Example for the one-to-one thread is Windows, Linux, Solaris 9 and later. Here we have the diagrammatic representation for the one-to-one thread, that is we have the separate kernel for the user thread. Here we have that a single kernel for that user thread. Next one is many to many threads. Allows a many user level threads to be mapped to many kernel threads, and it allows the operating systems to create the sufficient number of kernel threads. Next point is Windows with the thread fiber packages. Here we have the diagrammatic representation, that is we have the three kernel, it is interconnected with the different user threads. These four user threads are interconnected with this kernel thread. Next one is two-level model. Similar to the many to many, except that it allows a user thread to be bound to kernel thread. Example for this two-level model for is IRIX, HPUX, and then TRU64, Unix, and then Solaris is 8, and earlier we have the diagrammatic representation for the two-level model. Here we have that these kernels are interconnected with this many user threads. Like this, we have the single kernel thread is connected with that a single user thread. These are the diagrammatic for two-level model. Next one is threading issues. For this threading issues, we have the five key points. That is, first one is the fork and the execution system call. Next one is thread cancellation. Third one is signal handling. Fourth one is thread pools. Fifth one is thread specific data. These are the five points for the threading issues. Thank you.